The moons of Jupiter and Saturn may be the key to finding alien life. In the hunt for life outside Earth, Mars is old news. Um, Enceladus is an icy moon of Saturn, once overlooked by astronomers who figured it was too cold for life to have evolved there, much as they did with one of Jupiter's moons, Europa. Now, thanks to several scientific discoveries, including potential chemical, quote, biosignatures, scientists have begun to focus on the possibility that these celestial bodies could harbor microbial life. There are already tantalizing clues that basic forms of life may have evolved on other planets and perhaps moons of the solar system. Like on Mars, they found, I think, traces, but like they haven't said exactly. Um, but as in most fields of scientific research, one must step forward is sadly followed by two steps back. For instance, research in September that proposed that phosphine gas in the clouds of Venus could be a sign of life has been countered with studies that question those findings. Taken together, the studies indicate that the search for ET life in our solar system has broadened beyond an initial assumption that it might be found on planets like Mars or Venus. Several papers this year touch on the search for faint signs of life in our solar system, with a paper about Enceladus last month offering one of the most intriguing prospects. The paper is based on samples of the water plumes ejected from the planet taken by the Cassini space probe from 2005 to 2015. The probe found high concentrations of methane and unexpectedly high levels of hydrogen, which fit the idea that microbes have evolved to live around hydrothermal vents on the seafloor. That's cool. So this is one of Saturn's moons, Enceladus. Looks like it's covered in ice. That's cool. The ocean on Enceladus is thought to consist of salty water 12 to 15 miles deep, topped by up to 20 miles of icy crust. Scientists think that it's heated by the movement of the rocks of the moon core in Saturn's intense gravitational field, and that cracks in the crust created by the same tidal forces eject water from the ocean into space. And the methane in the ocean might be explained by purely chemical processes, but the study showed that it is, quote, very likely that it was made by microbes as long as it was accepted that life could evolve around hydrothermal vents, which we have that on our own ocean, and there's archaea. There's three main groups of life, right? Eukaryotes, prokaryotes, one does have the nucleus, one doesn't. And then the third is archaea, which are known as extreme organisms. They live in magma. We found them living in ice sheets. They're the ones that live around geothermal vents at the bottom of the ocean. It's just what it is. Hydrothermal vents, so-called black smokers on the ocean floor, thrive with microbes that feed on the chemicals emitted by the vents. They form the basis of a food chain that sustains entire deep-sea ecosystems of tube worms, shellfish, and crustaceans without the sunlight required by photosynthesizing plants. It's called chemosynthesis. Yeah. So there's also another study that the phosphine vapors could be caused by volcanoes. Europa, like Enceladus, is thought to also have a subsurface ocean of liquid water beneath its frozen surface, although little is known about it. But it's thought to be older, larger, and perhaps warmer than the ocean on Enceladus, which would that mean both of these planets are in the Goldilocks zone? I'm not exactly sure. This has been your host, Luke. Like this video if you liked it. Subscribe for more. I hope you have a good night. Thanks for watching.